Alright, so in this video, this is going to be on page 112 of your ISN. We are going to try to simplify the process of doing the derivative. So in our notes from yesterday, you can see that every single time we set up our u substitution and then we rewrote y in terms of u, did the derivative of each, multiplied them, and then cleaned up. That is great. If you can do that very well, then I'm very proud of you. However, there's going to come a point where you get tired of all that formatting. So in this video, I'm going to show you how to do it a little bit more mentally. And some of you, this might be a bit easier for you. So we're going to differentiate g of t equals -7 over the quantity 2t minus 3 squared. Alright, so identify first what our u is going to be. Just mentally, you can identify that, well, I know this is going to be my u. And if you want to, you can even write it off to the side somewhere so that you can mentally see that's your u. Okay, now if that's our u, then in your mind you can imagine that this is -7 over u squared. To do the derivative of that, we're going to need to move the u to the numerator. So let's just rewrite our g of t completely. Let's rewrite it as -7 times 2t minus 3 to the -2nd power. So again, you're visualizing that this is our u when we go to do the derivative. So why is it called chain rule? Well, this is going to help you more understand why the rule is called chain rule. When we go to do our derivative, g prime of t, remember the constant multiple rule says we can just leave the constant out front. So everything else is going to come behind it. I am going to pretend in my mind that this is u, and I know that if I had u to the -2, I would do power rule. So I'm going to do that. Bring out -2, leave parentheses, and reduce the power by 1. But instead of physically writing a u in there, I'm going to keep the 2t minus 3 because we just substitute it back in anyways. Then we're going to multiply by the derivative of what's inside, the derivative of u. And the derivative of what's inside is simply 2. So this is the derivative of u of the whole thing. This is the derivative of the whole thing. And this is simply the derivative of u. So I don't know if that makes sense to you, but that's how the chain rule works. And then we just do our cleanup. G prime of t equals, I can see I've got a -7, a -2, and a 2 to all multiply together. So I'm going to end up with 28. This quantity has a negative exponent, so it's going to go to the denominator, 2t minus 3 to the third, and we're done. Still makes a lot of sense to me. I can see where everything's coming from, but you don't have to have all that formatting. Let's try one more. This time, let's do they can get pretty difficult, so yeah, let's do y equals cosine of 3x squared. Let's throw a trig derivative in there. So remember, back before I would have you identify u, which mentally, hopefully, you notice that the 3x squared would be our composite function within the function cosine. But instead of actually doing all that formatting, we're just going to jump right to it. And we're going to say dy over dx equals, and let's just pretend that that isn't in there and it's just cosine of x. Well, the derivative then would be negative sine of, and whatever's in your argument, which here is 3x squared. So we're just skipping the actual u substitution part. And then we're going to multiply it by the derivative of what's inside. And what's inside's derivative would be 6x. And then we just clean up. Negative 6x sine of 3x squared. So it's called chain rule because you do the derivative of the thing as a whole, forgetting for a moment about that inside quantity, and then at the end you multiply by the derivative of what was in that quantity, whatever your composite function was. So a little bit less work, if that makes sense to you. If it doesn't, just keep going straight by the book, straight by the rules. Say u, say y, do the derivative of each, and multiply them. But basically, we're doing all of this work in our heads and going straight to this.